Let us discuss about the reactions of aniline. And reactions of aniline, basically the reactions of aniline involving benzene ring. Now if you look at the structure of aniline, this nitrogen has a lone pair of electron present which participates into resonance with the benzene. As a result, this NH2 group is, first point, is strongly activating group. Strongly activating group and enhance the reactivity of a benzene towards electrophiles. This is the meaning of activating group. Second point is that NH2 group is a group with a plus resonance effect. It increases the resonance that's why the R is there, increases the resonance of benzene, and the groups and the electrons are moving away from the NH2, that's why the plus sign is there. The lone pair of electron moves away from the NH2 towards benzene, and that's why the plus sign is there. And the third point is that NH2 group is ortho-para directing, means it directs the incoming electrophile only at ortho and para position. So these two positions are becoming more electron rich. So if you look at the resonating structures, ortho and para carbon, they are having a negative charge. So these are the resonating structures. So the first reaction is called abromination. Now since NH2 group is strongly activating, bromination of aniline gives a white precipitate of 2,4,6 tribromoaniline, and this is the reaction involved. It consumes 3 molecules of bromine to give 2,4,6 tribromoaniline. It is a white precipitate. And for monobromination, to introduce one bromine, we deactivate the benzene by acetylation. Acetylation means replacement of hydrogen of NH2 group by COCH3 using acetyl chloride. So this is called acetylation, reacting aniline with acetyl chloride. It gives this compound, and this compound is called N-phenyl acetamide, which has another name called acetanilide. So group still remains orthopara directing but slightly deactivating as compared to NH2 group. So once this acetanilide is obtained, using acetyl chloride, then we perform the bromination. The group still remains orthopara directing. So it gives two isomers, one is ortho, second is para. Although para is major one due to less crowding. So if you have to write only one product, you always write the para. Then we acidify this by using water. So it gives ortho-bromoaniline, and this gives a para-bromoaniline. So this is the way we perform the monobromination. So you have to slightly deactivate the benzene by acetylation before we perform the bromination. Now second reaction is called nitration. Now this is difficult to perform with aniline because the NH2 group is strongly activating. So if we are using aniline with HNO3 and sulfuric acid, this is acidic medium, sulfuric acid is present, so it gives para isomer as 51% and the meta isomer is obtained in substantial large quantity, this is 47%, and the ortho is obtained just 2%. So in acidic medium, this meta is obtained in large quantity. The reason is that in acidic medium, aniline gets protonated. It gets protonated to form, protonated means to accept H plus ion, to form anilinium ion, which is deactivating, electron withdrawing, and is meta directing. That's why meta is obtained in large quantity. So this is the formation of an anilinium ion. This is a acid base reaction. H plus ion is a Lewis acid and aniline is a Lewis base. It forms anilinium ion, which is electron withdrawing. This is anilinium ion. And this aniline on direct nitration with concentrated HNO3 gets oxidized to nitrosobenzene. This is called nitrosobenzene, and this concentrated HNO3 is a strong oxidizing agent. And oxidizes the highly activated aniline to nitrosobenzene. So nitration is difficult to perform with aniline. So in order to prevent formation of a meta isomer, formation of meta nitroaniline, and to prevent oxidation of oxidation of aniline by HNO3, we convert the aniline into acetanilide before nitration. Before nitration. Now this is aniline. So we use this indirect method to perform nitration. Now this is called acetylation. And then we perform nitration. The ring gets deactivated, slightly deactivated by using HNO3 and sulfuric acid. It forms ortho as well as a para isomer. This is the ortho isomer and this is a para isomer. So after nitration, we remove the acetyl group using H plus ion and water. So it gives orthonitroaniline and this gives a paranitroaniline. So this is the nitration of aniline. Now the third reaction is the sulfonation. Aniline on reaction with sulfuric acid initially gives anilinium salt. Now this is called anilinium hydrogen sulfate and this is unstable, and on heating it decomposes to give a product called para-aminose benzene sulfonic acid, benzene sulfonic acid. This is also called sulfonilic acid and used in the preparation of methyl orange, in the preparation of a methyl orange indicator, and it contains acidic group as well as a basic functional group. So they neutralize each other and gives a salt which is called Zwitter ion. So this is the Zwitter ion formation, which involves a transfer of H plus ion from the acid to base. This is called a Zwitter ion. This is salt formed as a result of H plus ion transfer within a molecule. Within a molecule, intramolecular. Now the fourth is that this aniline does not give Friedel-Craft reaction. It does not give a Friedel-Craft reaction, neither alkylation nor acylation. The reason is that aniline is a base, donates electron pair or lone pair of electron to a Lewis acid AlCl3. So C6H5NH2, it donates a lone pair to AlCl3. As a result, the nitrogen acquires a positive charge. This is a coordinate bond. The nitrogen acquires a positive charge. The benzene ring gets deactivated. And hence does not undergo electrophilic substitution in Friedel-Craft reaction. In Friedel-Craft reaction. So these are some reactions of aniline involving benzene ring.